Is it visible to you all? Is it visible to you all?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Fine. So, in the previous class, I'll just revise this part because circuit elements is something that we are going to use for today's different type of connection. Means we are today going to study about the series connection and parallel connection. So what we will see in a circuit, we will see that there is the resistances that we have studied, those are connected in series or parallel. But before that, along with that, there is always present an active component or element, which is this. I have earlier said that there will be a voltage source or a current source. In case of elements, there is always the circuit is complete with a compulsory presence of an active element and a compulsory presence of a passive element. Now, this passive element can be resistor, capacitor, inductor, anything. Okay. So, before that, the active element is the voltage source, or just like someone asked, it is just like battery in case of DC and an AC source, alternating current source in case of AC. Okay, so this source is a compulsory thing in the circuit, and another thing and other passive elements that those are present, that may be resistor, capacitor, inductor, anything. Now we are starting with the resistors part because we are going through DC circuits now, and at the same time, remember one thing: capacitors or inductors are present only in AC circuits. We are now studying the DC circuits, so we will be restricting ourselves to the resistance or resistors, and at the same time, whatever the active elements are, they will be supplying for the this passive elements. They are supplying the energy for the passive, the consumption or absorption, or we can say the requirement for the use of the load element, that is basically nothing but the resistors here in this case. So while we are going to study, we will just know about the two kinds of connection in which this resistance can be connected. These are series and parallel connections, and then again we will study about the combination of series and parallel connection. Okay, so let me just show you how series and parallel connection looks like. Okay, because it is very important about knowing the different types of connections here. So series circuit, I'll just show you. Is this visible to you all?
Yes, ma'am.
Am I audible now?
Yes, ma'am.
Is it visible to you all?
Yes, ma'am.
Yes, ma'am.
Fine, fine. There was a slight bit of technical glitch. Now it's okay. Anyway, so series circuit, we will mainly go through the different types of connection of the resistances or the passive elements. So here we are considering, since we are into DC circuits, we will go through the different types of connection. Uh, in in case of resistances, how the resistances can be connected, they can be connected in series or in parallel. So first connection that we will study, that is series circuit. Now what is a series circuit? Series circuit is one in which several resistances are connected one after another. Okay, this connection or such connection are also called end-to-end connection, and there is only one path of the flow of current, means only the same current is flowing through all the resistances. Now we will see that as per the figure, as you can see in the figure, diagram is visible now clearly to you all.
Yes, ma'am.
Good, fine,
Yes, ma'am.
fine. So from the diagram you can see that there is this circuit which has a voltage source, means the active element voltage source is termed as V, given by plus minus sign as a battery. So that is our active source or the voltage source. Now active component of voltage source, this supplies the current into the entire circuit. Into the entire circuit means what is about the circuit? There are three passive elements, called, we can say that there are three passive elements which are nothing but resistances, but different resistances, values are different. R1 is the value of first resistance, R2 is the value of second resistance, and R3 is the value of third resistance. So basically this voltage source is supplying for the three passive elements R1, R2, R3, and the current that is being flown through this circuit is I. Same current flows through R1, the same current is flowing through R2, and the same current is flowing through R3. But the voltages are different across this particular elements or the particular resistances. Across R1, the voltage drop is V1. Across R2, the voltage drop is V2, and across R3, the voltage drop is V3. Now, someone asked me in the previous class, what about the voltage drops there? Means already the voltage source is given as V. So, what is V1, V2, V3? You see, as per Ohm's law, there will be certain amount of voltage differences existing. Then only the current will be flow, then only the current will flow as long as there is voltage drops. Okay, now this, according to Ohm's law, we can write in this circuit that V1 is equals to I multiplied by R1, V2 equals to I multiplied by R2, and V3 equals to I multiplied by R3. So current through all of these are same. I is the same. Okay, so voltage V1, V2, V3, these are different in case of series circuit. I'll go to the parallel circuit, but just for telling, I am telling you, this is just in case of parallel circuit, it is opposite. There, the voltages are the same, but current is different. Just for your information, we will go to that later. First, series circuit, let us see. The resistance R1, R2, R3, these are be in series. Okay. Now the combination of this is connected across a source of voltage V volts. Now V1, V2, V3 are the voltages across the terminals of resistance R1, R2, R3. Means across R1, means suppose the resistance R1 only you consider. only R1, the starting of R1 and ending of R1, those 2 points. In those 2 points, across those 2 points, the voltage is V1. Across the starting and ending of R2, the voltage across R2 is V2. And starting and ending of R3, the voltage is V3, as it is shown in the diagram clearly. Okay, so I'll just tell you about what about the if we add up all the voltages, means the supply voltage, then we can write the equation. Just see about the equation I am giving you. Is it visible?
Yes, ma'am.
Yes, ma'am.
Okay. So according to Ohm's law, as we saw that V1, V2, V3 was equals to IR1, IR2, IR3. So if we add up, then we can write that V1, V2, V3 are the voltages that are basically supplied by the active source or the voltage source V. So V is equals to V1 plus V2 plus V3. So according to Ohm's law, we can just put the value of V1, V2, V3 into that equation, and add up, we get that according to Ohm's law, V is equals to IR1 plus IR2 plus IR3, which is equals to I multiplied by IR1 plus R2 plus R3. Okay, anyone has any question, please ask. Anyone any question, please do ask. Till now, any equation that is not understandable or not clear? Am I audible and visible also? The PPT is visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, yes. Any questions from anyone, please? Means why is this V divided into V1 and V2 and V3? See, in case of series circuits, always remember, in case of series circuits, the current is same, but the voltage is different. Okay. And in case of parallel circuits, the voltage is same and the currents are different. If you go through terminal wise, then only you will understand. You see, V is the total voltage, right? So obviously, if it is a series one, means end-to-end connection of resistances, then obviously the there is no division in current. Only one path is there. There is only one path in the flow of current. So obviously, in that one path, the voltage will be divided among itself in the resistances. And if it is a different path is there, there is branch in a particular circuit, like in parallel circuit, then the current is divided and the voltage terminals are the same. Just like that, imagine that in case of series circuit, if it is there, the resistances are end-to-end connection and there is only one path of the flow of current, then obviously the current is flowing of only one value. There is no other value of current. But if there is a division in current, then the current will divide among itself. Is it clear, everyone?
Yes, Yes,
Okay.
ma'am.
So in this series circuit, we get the equivalent resistance as, you see, this R1 plus R2 plus R3. This one is actually written as Req, where Req is the summation of R1 plus R2 plus R3. So in case of resistances, we add up. We add up the resistances in case of series connection. That means Req is equals to R1 plus R2 plus R3. So whenever there will be series connection of resistances, we will write as Req equals to R1 plus R2 plus R3. Okay, so this is about our summation, or we can say for n number of connection of resistances, we can write Req equals to this value. Whatever be the number of resistance, if it is in if it is in series back to back, then we will add up the resistances. It is the arithmetic sum of the resistances connected in series. So here is a characteristics that I have written. These are the characteristics of series circuit. So series circuit, we will remember these points. Number one is that same current flows through each resistance. Number two is that the supply voltage V is the sum of the individual voltage drops across the resistances. That is, V is equals to V1 plus V2 plus V3 dot Vn. Okay, so V is also the sum of individual voltage drops across the resistances. Okay, next is that the equivalent resistance is equal to the sum of the individual resistance. Means this Req is actually equals to plus of all the resistances. So that is the thing. Req, they are saying that the equivalent resistance is equal to sum of the individual, or you can write arithmetic sum of the individual resistances. And the last one is that the equivalent resistance is the largest of all the individual resistances. Just see this Req. This Req is the greatest of all than R1, than R2, than R3, because it is the sum of all. So Req is the largest of all R1, R2, R3, R4, because it is the sum. So that is why this equivalent resistance, in this characteristic, they have said that the equivalent resistance is the largest of all the individual resistances, which is R equals R greater than R1, R greater than R2, and R greater than Rn. Okay, so this was about the, so in general we can say that this is all about our series circuit. Everyone understood? Any questions?
No,
And
ma'am.
please go to the characteristics.
Characteristics, okay. Yes. Tell me, which one do you need an
No, ma'am,
explanation?
writing it.
Oh, you are writing. Very good, very good. Yeah, take your time. I'll be giving a series circuit representation in problems. So we will be doing a problem today. Uh, if anything, it is also, it involves the previous classes formulas, means for the power and whatever energy, the power, those things are also required. So we will go to that problem and we'll solve that also. Let me know when you have already written, okay?
Done, ma'am, thank you.
Okay, is it over? Can I change now?
Yes, ma'am.
Fine, fine. So this one was about the series circuit. Let us just go to the parallel circuit. Okay, this is an example of parallel circuit where it is not, the resistances are not end to end connected. Means the resistances are connected across each other. Means, for example, take the starting and ending of resistance R1. So starting and ending of R1 is same as starting and ending of R2 is same as starting and ending of R3. That is called a parallel connection. Okay. So the parallel circuit is one in which several resistances are connected across each other, means in parallel to each other, parallel to one another, in such a way that one terminal of each is connected to form a junction point while the remaining ends are also joined to form another junction point. Okay, so this is our parallel connection. So can you differentiate between series and parallel circuit, series and parallel connection? Is the difference between series and parallel connection clear, student?
Yes, ma'am.
Yes, ma'am.
In
Yes, ma'am.
Yes, ma'am.
series,
Yes, ma'am. I mean,
Oh,
series.
yes.
in
In
series
series.
current is
In series
constant
connection.
and in
Yes.
parallel voltage is constant.
Right, absolutely. Very good. So, very good. I'm happy that you have understood. Anyway, so moving on to this, in parallel circuit, the current passing through each resistance is different. Okay, so let the total current drawn, means suppose in this circuit the total current is I. Okay, see here the current is dividing in the parallel paths. I1 is divided to go through R1, I2 through R2, and I3 through R3. It is passing. But the voltage is given across the two terminals. The two terminals are same, only that those two terminals only, R1 is connected, R2 is connected, and R3 is connected. So the terminals are same, so obviously the voltage will be same. If the terminals were different, the voltage would have been different. Since the terminals are same, so across those two terminals, obviously the voltage is also same. There is same voltage across the 2 points. Voltage, always remember, they are seen or observed through the terminal points. If the terminal points are same, the voltage across those will be same. If the terminal points are different, the voltages are different. Understood, everyone?
Yes, ma'am.
Okay,
Yes, ma'am.
good. Fine. So we will just move to the same Ohm's law that we were comparing with. So in parallel circuit, they are saying if the current passing through each resistance is different, let the total current be I. And there is there are, you can see, three different paths for this current: one through R, second one through R1, second one through R2, and third one through R3. Now these individual currents are shown as I1, I2, and I3. So the voltage across the two ends of each resistance, R1, R2, and R3, is same and equals the supply voltage V. Hence, if we apply the Ohm's law, we will get V equals to I1 R1, the same V is equals to I2 R2, and the same V is equals to I3 R3. Means the voltage is same, current is different. So from here you can find out current, different values of current I1, I2, I3 as V by R1, V by R2, and V by R3. Okay. So also at the same time here just the reverse case happens, that is I total current is equals to I1 plus I2 plus I3. So we can write it down as the equivalent. If we want to find the equivalent resistance here, that basically becomes equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is 1 by R equivalent, mean the total resistance. Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, miss.
Okay. You can write this down, the expression, because I will just move on for the problems. Let me know when you have written it down. Is it over? Written it down?
Yes, ma'am.
Fine. I'll just move on to a problem now because we don't have much amount of time. So I'll just show you a problem. I want you all to solve this. Okay. I'll not show you about the, yes. Just write this problem down. Three resistors, 100 ohm, 200 ohm, and 300 ohm, are connected in series to a 250 volt supply. Determine the current in the circuit and power dissipated in each resistor. So this is the problem. I'll see whether you can do this or not. I have it solved, so I'll show you finally. But you try once on your own. I'm telling you the hints about this. See, there are three resistors: 100 ohm, 200 ohm, 300 ohm. These are connected in series, right? So obviously, if they are connected in series, the equivalent resistance is the sum of all three. If you have the sum of all three connected and you have the voltage also given, you can find the current, means equivalent resistance is given, voltage is given. So current will be I equals to V by R or R equivalent.
Ma'am, current is 0.416 ampere.
Okay, and they have also asked for power dissipated. Tell the power value. Power dissipated in each resistor. How will you find the power? The formula of power, if you remember, there are two formulas of power.
A is equals to VI.
Yes, yes.
14.1 watt, ma'am.
This is the power of which one? I will say what you are thinking. Okay, I'll just tell you once that you are thinking that power will be V into I, right? There are two other formulas of power. One is I square R, another is V square divided by R, right?
Single resistance or equivalent resistance we have to take, ma'am?
Yeah, see, they have asked in the problem, it is given only. The problem, it is said that power dissipated in each resistor, means एक एक में कितना dissipate हुआ, means all the three, each one, how much of power each one has dissipated. So if each one of power is dissipated, obviously current is same, voltage is different. So we will definitely for each one take the different voltages. So V square R will be the formula, right? V square divided by R.
Ma'am, first
Is
one
it
625 watt, ma'am.
right? And just tell me how you calculated that.
V square by R.
Right, R1, not R equivalent, because it is exclusively
Yes,
to
ma'am.
that resistor.
And second
Okay.
one 314.5 watt, ma'am.
V by R2, and third one V square by R3.
208.3, ma'am. Third one.
Okay, I'll just show you the results, and to those who have not done or could not understand, for them also I'll just see the answer I'm giving you. Here they have written in both the formulas. You see, one is I square R1, I square R2, I square R3. You just verify whether they are becoming same or not. You have done in V square by R1, V square by R2, V square by R3. So that is V1, V2, V3. Okay. So according to V1, V2, V3, whatever it is coming, V1 square by R1, is it same as I square by R1 or I square by R2? That you just verify. Here it is shown ultimately that whether the two powers are becoming same or not by using both the formulas, whether the total power loss is same in case of just like P equals to VI, or it is same as V square means I square R1, I square R2 or I square R3 or not. Just check out using whatever method you have used.
Excuse me, ma'am.
Is it coming same?
Ma'am, by using P equal to V square by R, it came a little different.
V square, which one has you have you taken? V1 square it will be na, because voltages are different across them na. You can do one thing. If you have a doubt, individually you can just take a picture and send me in WhatsApp. Then I'll be clearing you individually.
Ma'am, I think using V square by R formula will be become more lengthy. So I square R will be more easy to solve.
Right, right. You are right. We can use any formula actually. Okay, smaller and bigger, that is up to you. You can use
Ma'am,
any
excuse
of
me,
them.
to use V square by R, we have to first find voltage in each circuit also.
Right. V1 you have to separately find, V2 you have to separately find, V3 you have to separately find. If you don't, you can use this. This one is the shortest one. You can, as he said, this is actually a short one. It will take less amount of time. Everyone have understood this sum problem, have taken down in your copy. Please take this in your copy. You write it down because we will be moving on to the next one.
Done, ma'am.
Done? Everyone, please respond.
Yes, ma'am.
Yes, ma'am.
Fine. Now, suppose if this is a problem where we have all the informations. We have the value of R1, R2, R3. We have the value of voltage. Only the current that we will have to find out. And using current, we have found out the losses here. Okay. So, if something is not given, means like one of the resistances is not given, but they have said about the voltage and current also they have said, so you will be able to find out the resistance.
Yes, ma'am.
Yes, ma'am.
Right. Similarly, any of the parameters can be missing and they have said you to find that parameter. So that will be easier for you now. Means at least you know the methods of how to calculate in a series connection the power, current, or resistances if it is unknown. Right. So next we
Yes,
will
ma'am.
be moving on to a sample problem. You can write this problem down and try to solve it.
Ma'am, screen is halfly visible. Can you?
This is only the part of the problem. I actually, the rest is the solution. As I want you all to do the solution, that is why I am showing only the problem statement. I'll help you to find the solution, don't worry. Have you taken down the problem, everyone?
Yes, ma'am.
Fine. Uh, just listen first. Okay, listen first. Everyone, listen. Here we have an unknown resistance R that they have told us to find. Find R is the problem. We have to find the resistance R. Okay. Along with R in series is 20 ohm resistance. And there is a supply of 220 volt. Okay. So this is a series connection where R is the unknown. We have voltage, we have another resistance, but we do not have the value of current, but we have the value of power loss is 50 watts that is given. So the power loss in R is 50 watts that is being given. So from there we can find out the rest. Anyone wishes to try this problem? Otherwise I'll explain the problem.
Ma'am, in the place of R2, we can write 50 by I square. So first we get the value of I, and then with the value of I, we can get the value of R.
Absolutely right. For the others, I'll show the problem. Okay. The main thing is I'll show you the method, but the answer I want you all to give, because answer is something which has to be solved and given. Okay. So I'm just showing you how it is done.
948.
Just see it whether this is how the problem will be done. Okay. They have said that consider that the total resistance is RT, which is actually sum because it is in series. So equivalent resistance of the total resistance RT is equals to 20 plus R. Okay, total or equivalent resistance. Now the current in the circuit is obviously the same current will be flowing series connection. That is why if the same current flows, then 220 divided by 20 plus R is our I, or the total current. Now the power loss is already given, which is 50 watts. Now power loss is I square R. So I square R is total equivalent resistance. Okay. So only across R, the power loss is I square R, which is the current square multiplied by R equals to 50. Now what happens? This is the formula which is coming out of solving this. Anyone has any question? Just ask me. Tell me which you are not understanding. Just tell me.
No, ma'am.
Everyone else? Everyone. I'm not asking only 1%. Everyone Uh, any question?
No, ma'am.
No, ma'am.
No, ma'am.
ma'am.
No,
No,
ma'am.
ma'am.
Is it clear?
Ma'am,
Yes, yes, please.
ma'am, initially, can we use that formula P is equal to VI, ma'am, uh, to find current?
You try that formula also. This in circuit theory or in basic electrical, what happens? Multiple formulas can be used. It is not that this is only the method. You try in that way also, and you show me. No problem. Okay, you show me, and later I'll get you cleared with the problem, your method. You just apply and see whether it is happening or not. Okay. I'll be just dealing with this last problem because time is already over. Okay, so we are out of time. You try this problem out. Uh, till this thing I have shown you, but are you all familiar with this solving this equation? Anyone?
Yes, ma'am.
How will you
Yes,
solve
ma'am.
this?
By
What is
making perfect square method.
Sridharacharya formula, right? I don't know
Yes,
whether you
ma'am.
call it perfect square method or not. That is the Sridharacharya formula that we get if we want to find any root or any value of x, unknown value of x, when the complex equation forms. Then we take the help of Sridharacharya formula and we find out by using minus b plus minus root over b square minus 4ac divided by 2a. Right?
Yes,
Yes,
ma'am.
ma'am.
I think many of you are not clear with this. Please let me know individually in WhatsApp. I'm sending this to you all. Okay. Just try this. If you are clear, if in any portion you are not clear, let me know. Okay. Definitely you should let me know. So I'm ending with this series connection only today. Next class, I'll go for more problems and parallel connection as well. Okay. So for this class, this is over, I think. I'll be giving you all the notes and everything. Try this out. If you do not understand, please let me know. Okay. Everyone, to everyone, I am telling. Those who are solving very good, well and good. Those who are not solving or cannot solve, for them also, kindly let me know. Just let me know. That will do. Okay, everyone. So this is the end of the class. I'll be just stopping the record.
Thank you, ma'am.
Thank you, ma'am.
Okay, you can leave. Thank you, everyone. I'm leaving the Google Meet. You can also leave now. Thank you.